there is something known as decision-making statements. So let's understand these decision-making statements in a proper way. Now, there are many real-world situations where you'd have to make a decision on the basis of a condition. So you can either do this or you can only do that, right? So you basically have an option to decide. So you either take the first option or you take the second option, or maybe you have a lot of options, right? So sometimes there's a case that you either choose option A, option B, option C, or option D, or so on. So this is where you would need decision-making statements. So let's take this example to understand it better. Now, let's say you actually want to play football, but the condition is you can only play football if it doesn't rain. So this is how you can use decision-making statements. You'll start with if, and then you'll make the statement, which is if it's raining. So if it's raining, you obviously can't play football. So you'll just go and sit inside and maybe watch a movie. But on the other hand, which is else, if it is not raining, then you can happily go out and play football. So this is how you can establish a real world condition with the help of decision-making statements. Now let's look at another example. So let's say you really want to eat ice cream, but your mother gives in a condition that only if you score marks greater than 70, that is when you'll get an ice cream. But on the other hand, if you score less than 70, then you'd have to give a practice test. So that is what we are depicting over here. So if your marks are greater than 70, then you're rewarded with an ice cream. But on the other hand, if you actually score less than 70, then you'd have to give in another practice test, which you don't want, would you? So this is the pseudo code of an if-else statement. So first you type in if, which is the keyword, and then you give in the condition. Now, after you give in the condition, if the condition evaluates to true, that is when you'll go inside the body of if statement and those conditions are executed properly. But on the other hand, which is else, if the condition is evaluated to false, then you will execute these statements. So first, it will be condition 1. So if this condition is true, then you'll execute all of the statements which are present inside this. Else, if it is false, then you'll execute all of the statements which are present inside else. So this is how if-else works. This is where looping statements come in. So as the name states, loop is basically you do the same thing again and again. Now let's take this example over here. Now let's say you want to fill in a bucket entirely with water, but to do that you only have a mug. So what you do is you take in a mug of water and you pour it into the bucket, and then again you take in a mug of water and you pour it into the bucket. So you basically repeat this process until the entire bucket is full with water. So over here the task is taking one full mug of water and pouring it into the bucket. So over here the condition is until the bucket is full. So as you see, while the bucket is not full, you will keep on filling it with this mug of water. So over here you are repeating the same task again and again until the condition is satisfied. Now we've got another example over here. So let's say recently you have discovered a new song by the band Metallica, and you're just hooked onto that song, and that is the only song which you want to listen to the entire day. So what you're doing is you are playing that song on loop, or you're basically repeating that song until you close the app, right? So this is again an example of a looping statement. So until you close the app, the same song will keep on repeating. Now we have another example. So let's say you are a working employee. I mean, all of us work to get paid, isn't it? No one works for free. So at the end of every month, so whether it is 31st or 30th, so basically at the end of every month, we get our salary credited into our accounts. Oh, that happy feeling, right? So this is again another example of a looping statement where we get our salary credited at the end of each month. So this process basically continues until you leave the company, or maybe you're fired from the company, which obviously you don't want to happen. Now let's look at the pseudocode for while loop. You will type in while, which is the keyword. So inside this you will give in the condition. Now you are checking if the condition is true, then you will go ahead and execute the statement. So this while loop will go on until the condition is true, and once the condition is evaluated to false, you will come out of this statement. Now it's time time for another important concept where we'll understand about functions in real life. Now, let's say you're eating or running or cycling. What are all of these? These are just functions, aren't they? Eating is a function, running is a function, cycling is a function, and these are functions which you do in your real life. So, if you want to depict these functions in a programming world, how do you do it? Well, it's sort of the same concept. Now let's take this example of an ATM machine. So you've got these three different options when you go to the ATM machine, don't you? So you can either deposit your money, or you can withdraw cash, or you can check your balance. So you basically got three different functions over here. Now, either you can put in your money into the ATM machine, which will automatically be credited back into your account, or you can withdraw cash from the ATM machine, or you can check your balance. So for these three different functions, now if we take this first function over here, which is depositing money. So to actually write this one function, you would need, let's say, easily 1,000 lines of code. And maybe if you go to the nearby ATM machine, there are hundreds of people depositing money, right? So you can't be writing thousands of lines of code for every time someone deposits money. So this is where what you can do is you can create one simple function called deposit, and you can keep invoking that function whenever a person has to deposit money. Similarly, whenever a person has to withdraw money from the ATM, or whenever someone has to make an online transaction, so all you have to do is create a function withdraw, which will have those 1,000 lines of code, and you can easily invoke that function whenever someone has to withdraw money. And then we've got balance, which is the same thing. So there easily must be more than 1,000 people who would check their balance. So what you do is you will create a function which will show the balance of the person to him or her. And whenever the person invokes this function, it is automatically done. So this is how you can work with functions in the programming world. Now we'll head on to the most important part of programming, which is known as object-oriented programming. So what do you see around you? You are surrounded with objects, aren't you? So you've got your phone in front of you, you've got your bike, even your pet dog is actually an object, right? So all of these are nothing but objects. Now these objects are basically associated with two things. These objects have properties and they have something known as behavior. So there is something known as a class, which is basically the template or a blueprint for real world entities. So let's take the case of a phone. Now, if we want to have a blueprint for this real world entity, which is a phone, now there are two basic things which are associated, which is the properties and the behavior. So the properties of a phone could be its color, its cost, and its battery life. And then if you look at the behavior of a phone, you can make calls, you can play videos, or you can even play games on your phone. So when you combine properties and behavior into one single template, that is when you get a class of a real world object. So it's as simple as that. So now that we've understood what exactly is a class, let's again understand what is an object. So I've already told you that we are surrounded with objects, and we also know that these objects have a specific template to it. So if you look at this, objects are nothing but specific instances of a class. So you take a template, and then if you want a specific instance of that template, that is when you have an object. So let's take this example of this mobile phone. So mobile phone would be the class, and the specific instances would be the objects. So over here, the specific instances would be Apple, Motorola, and Samsung. So the term phone or mobile phone would be your class, and the brands of phones. So Apple is a brand of phone, which would be the object. Motorola is a brand of phone, which would be the object. And Samsung is a brand of phone, which again would be the object. So now, another thing you need to keep in mind is all of these objects, since are part of the mobile phone class, they would be having the same set of properties and behavior. So when it comes to the Apple phone, it would have a specific color, it would have a cost, and it would have a proper battery life. And also with this Apple phone, you'll be able to make calls, you'll be able to watch videos, and also play games. Similarly, it's the same thing with this Motorola phone. So this Motorola phone would have a color, it would have a cost, it would have a battery life, and also you can make calls, watch videos, and play games. So now you guys must be thinking, what is the difference between these objects? Well, all of these objects would have different values for these properties and different values for these behavior. So the color for all of those three phones would be different. The cost of those phones would be different, and also the battery life would be different. Similarly, making calls would be a sort of a different behavior for Apple, and also maybe you'd have to click on some other button to make a call from your Motorola phone. Right, so this is how these objects differ, but all of them would come under the same umbrella term, which is class of a mobile phone. So now that we've understood what exactly are functions and what is object-oriented programming, now we'll see how can we solve a real-world problem, or what are the steps, or what is the method to solve a real-world problem. So let's say you want to make a lemon juice. You're craving for lemon juice because it's summer and it's really hot outside. The problem over here is, how do you make lemon juice? So let's see how can we find the solution. So what we do is, we'll take a step-by-step approach. So first, we'd have to check if we have all the ingredients to make lemon juice or not. So you would need lemons, obviously, to make lemon juice. Then you would need a glass of water, you would need ice cubes, and you would also need sugar or salt according to your preference. And now, if you don't have all of the ingredients available, that is when you'd actually have to go back and get all of the ingredients. So this is the first step. Now that you've got all of the ingredients, then you'll go ahead and cut your lemon into 2 halves. And after cutting the lemon, you'll squeeze that lemon into a glass of water, and then you'll add sugar, and then you'll stir it really well. After all of this is done, all you have to do is add in ice cubes and then serve it to all of your guests. So this is the step-by-step approach to making lemon juice. Now, this is what is actually known as an algorithmic approach. So you have a problem to which you're trying to find out a solution, and you will come to the solution by having a step-by-step approach. So let's say you have the input. Now you'll have a certain number of steps to be followed, and then you'll come up with the output. So this is what is known as an algorithm to find out a solution for your problem statement. Now let's take this problem over here. So let's say you are given a number and you have to find out if the number is even or odd. So this would be the step-by-step approach. First, you'll start off by taking a number. So let's say the number given is 10. Now what you'll do is, you'll take that number and you will divide that number with 2. So if the remainder, when you divide 10 with 2, is equal to 0, that is when you'll say that it is an even number. Otherwise, if the remainder is not equal to 0, then you'll say that it is an odd number. So this is how you'll come up with this algorithm. Now, similarly, let's say if the number is 7. So again, you'd have to do the same thing. So you'll take in 7 and then you'll divide it with 2. So if the remainder is equal to 0, then it's an even number. On the other hand, if the remainder is not equal to 0, then it's an odd number. So obviously, for 10, it is an even number because remainder is equal to 0. And for 7, it is an odd number because remainder is not equal to 0. So this is how you can formulate an algorithm to come up with a solution for the problem statement. So this was an introduction to programming. So basically all of the concepts of what a programming language has. Now we'll head on to Python. So let's start off by understanding what exactly is Python. So simply put, Python is a free and open source programming language. So when I say free, it's just plug and play. All you have to do is download it and then you can happily start working with it. And also it's open source. So when I say open source, you can actually modify the code and add your own innovations to it. So isn't that truly amazing? And Python is also cross-platform compatible. So what do I mean by that? Well, you can run the Python programming language on any operating system. So whether it is Windows, Mac, Unix, Linux, any operating system it is, you can run the same piece of code on any operating system. So that is what is known as a cross-platform compatible language. And then Python also provides a large standard library. So whatever your task is, Python provides a library for that. So if you want to do data manipulation, Python provides a package for that. If you want to do web development, Python provides a package for that. If you want to do data visualization, Python also provides a package for that. So whatever your need is, Python springs up a library from its hat. And as we've already seen, Python is also an object-oriented language. So whatever data you have around you, you can represent all of that data in the form of objects so that you can find a solution with whatever problem you're headed to. So now that we've understood what exactly is Python, let's see how can we install Python in our systems. So to install Python, we have to go to this website, python.org downloads. I'll just click on this. So let's just wait till the site opens up. So as you see, we've got the latest version of Python over here, Python 3.8.1. So if you're using a Windows system, then you can download Python for Windows. If you're using a Mac, then you can download Python for Mac. Or if you're using a Linux system, then you can download Python for Linux. And since I'm using a Windows system, I'll just click on this, download Python 3.8.1, and the download would start. So it's as simple as that, guys. So since it's a free software and an open source software, you just have to go to this website and click on this download button and the download would start. Now, working with Python is easy, but what makes it easier is to work with an IDE. So IDE basically stands for Integrated Development Environment. So this Integrated Development Environment gives you a bunch of tools which makes writing code extremely easy. So one such IDE is PyCharm. So let me just go to this site. So you have to go to jetbrains.com PyCharm and you can download PyCharm from over here. Alright, so you just have to click on download and you got the professional version and you got the community version. So this is the free open source. So you just click on download and the download will start over here. Now for our programming part of it, we'll actually be working with Jupyter Notebook and we'll have to install Anaconda for that. So to install Anaconda, we'll go to anaconda.com. So Anaconda is again a sort of an IDE. Well, not just an IDE, it's actually a distribution which would provide you everything. So it is actually a web-based distribution. So as you see over here, Anaconda is useful for data scientists, IT professionals, and also business leaders. And now let me just show you how can you download it. So you just have to click on download over here, right? So as you see, this is basically a distribution, and with the help of it, you can basically code in Python as well as R language. But Anaconda distribution is mostly used to work with the Python language. So it provides a lot of tools for you. So you can quickly download more than 7,500 R and Python data science packages. And it also provides multiple libraries, dependencies, and environments. So you can also work with deep learning models. So this Anaconda distribution provides you scikit-learn, TensorFlow, and Theano, right? And also if you want to do data visualization, then it provides all of these libraries inbuilt. So you've got Matplotlib, Bokeh, Data Shader, and HoloViews, right? And these are the different libraries and different notebooks which you've got. So we'll be basically working with the Jupyter Notebook. So this Jupyter Notebook and all of these set of libraries come inbuilt in the Anaconda distribution. So I'll just click on download. And since I'm using a Windows system, I'll click on Windows over here. Now, also if you've not installed Python earlier, you just have to click on this download button, and this Anaconda distribution will also automatically install Python for you. So all you have to do is click on download. And since I want the latest version of Python, all I'll do is click on this. So over here, the latest version of Python is 3.7, and I'll click on download. So also the download has started over here. Now, when you do this, you'll basically have different options over here. So I'll just type in Anaconda. And when I type in Anaconda over here, I've got Anaconda Navigator as well as Anaconda Prompt. So this Anaconda Navigator is basically a GUI with which you can work with multiple tools. And this Anaconda Prompt is the command line interface for Anaconda. So let me just show you the Anaconda Navigator first. I'll click on this. Right, so we have successfully opened up Anaconda Navigator. So as you see, we've got all of these different tools over here. You've got Jupyter Lab, Jupyter Notebook, PowerShell, Qt Console, RStudio, and so on. Now this Anaconda Navigator would have different environments. So we'll be working with mostly the base environment over here. You've got these tabs, you've got learning. So if you want to learn something about pandas, so you've got all these libraries over here, right? So if you want a basic Python tutorial, then you can read upon this. If you want a tutorial on Anaconda, you can read upon this. And you've got these libraries which are inbuilt in Python. So you've got pandas, numpy, scipy, matplotlib, and so on. So you just have to click on read, and then you'll have a documentation for all of these. And also Anaconda has this huge community over here. So you've got all of these conferences, and if you want to learn something new, you can easily learn it from this huge community which is present. So this is the GUI part of the Anaconda, and it is known as Anaconda Navigator. So let me just close this up over here. I'll click on yes because I want to quit. And now I want to work with the command prompt. So I'll open this Anaconda prompt. So this is the base version. So now I have to open up the Jupyter notebook where I'll be writing all of the code. So to work with the Jupyter notebook, I'll just type in Jupyter and then I'll type in notebook over here. And let me just wait till the Jupyter notebook opens up. Right, so I have successfully opened up the Jupyter notebook.